This is going to be a quick introduction to sequences. A lot of what we're going to talk about today is going to be review, but we need to review it so that we can get into the calculus part of it. So a sequence is really just a list of numbers. Now, formally in math, we would define a sequence as a list of numbers written in an explicit order. The order is important here. So we can't just have a random list of numbers without any kind of, order, but it needs to be in a certain order. So typically these sequences are given to us as a formula, and the formula allows us to compute each term in the sequence either explicitly or implicitly, and we'll talk about what that means in a moment. So a sequence is essentially just a list of numbers. We write it like this: a sub n. Sub means subscript. So a sub n, this is the nth term in the sequence. So a sub 1 would be the first term or the first number in the sequence. A sub 2 would be the second term in the sequence. You guys have seen this notation before, right? Okay. So an explicitly defined sequence is a way of defining each term of a sequence independent from the other terms in the sequence. So basically it's just a formula that says if you know what term number you are on, then just plug that number in for n and you're going to figure out what that term is. So this is an example of an explicitly defined sequence. And if I want to find, say, the first term in the sequence, a sub 1, what do? Plug 1 in. So I'm going to do negative 1 to the first power over 1 squared plus 1. And so we would get negative 1 over 2, and that's a sub 1. And if I want to know what the second term is, I plug 2 in, so I'd have negative 1 to the second power over 2 squared plus 1, which would be positive 1 over 5. And I could do this for any number I wanted. I could figure out what the 100th term is. That would be negative 1 to the 100th power over 100 squared plus 1. Now, a quick note about this, the negative 1 to the nth power. This is something we're going to see a lot. And what's that going to do to a sequence of numbers? It's going to alternate it between negatives and positives. So if negative 1 to an even power is going to be what? Positive. Negative 1 to an odd power is going to be negative. So negative 1 to the 100th power, is that going to be positive 1 or negative 1? That's positive 1, so we're going to get 1 over 10,001. And that's going to be the 100th term. So this explicitly defined sequence is just a way of defining each term in the sequence independent of the others. We just plug in n, we get what that term is going to be. An implicitly defined sequence is a way of defining terms in a sequence depending on the previous term or the previous terms. It doesn't have to be just the one before it. In fact, it doesn't even have to depend on the one before it. It could be any term before it. Or it could be a combination of terms before it. So this right here is an example of an implicitly defined sequence. There's a problem here, though. So what this says is the nth term in the sequence b, so b sub n, is going to be equal to the term before it plus 2. So what's my problem? What's that?
You don't know the number before it.
I don't have any numbers as a starting point, right? So if we're going to implicitly define a sequence, we also need to give a starting point. So I would have to say the first term, or the first two terms, or some starting point is equal to something. So let's say b sub 1 is 4. Then I could use this along with this to figure out what b sub 2 is. Because b sub 2 is going to be b sub 1 plus 2, which would be what? 4 plus 2, which is 6. Could I figure out right now what b sub 100 is using this formula? No. The implicitly defined sequence have a pretty strong limitation, a pretty big limitation, in that you have to know what the term is before it before you can find the next one. So to find the 100th term, we have to figure out what the 99th term is. And to find that, we have to know what the 98th is. So we basically have to go all the way up from 1 to 100. So what we're going to do a lot of times with implicitly defined sequences is we're going to try to write them explicitly. We're going to try to figure out what the formula is going to be. In this case, the formula is going to be 2 plus 2n. And that would give us an explicitly defined sequence. And we're going to be able to convert back and forth more from implicit to explicit because that's more practical. So many sequences that we're going to come across can be defined either way, explicitly or implicitly. Some can only be defined one way. The Fibonacci sequence is a good example of one that cannot really be defined explicitly, but we can only define it implicitly. Meaning we have to know what two terms are to get the next term. Now, there are ways to approximate numbers in the Fibonacci sequence, but we still have to know what the two terms are before. Are you guys familiar with the Fibonacci sequence? So a sub 1 and a sub 2 are both 1. So the first two are 1. And then the next term, we take the term before it plus the term before that. So what's that going to be? 2, then 3, 5, 8. We get each one of these by adding the two terms before it. There is no way to figure out what the 100th term is going to be without computing the 99 before that. It will be difficult for us to work with sequences like this that can only be defined this way because the stuff that we're going to do that relate to calculus and limits, we're going to do that stuff on the explicit formulas. So when we have stuff like this, we would have to find ways of getting around that. And luckily for you, as far as this class goes, we're not going to have to do that.